Welcome to The Explainer. Today we're going to peel back the layers on an operating system you've definitely heard of, but maybe didn't realize is the absolute backbone of cybersecurity, Linux. We're going to break down how the pros use it to hunt for threats and, defend the digital world we all live in.
So let's just jump right in with a pretty staggering number. Over 90%. Over 90% of all cloud infrastructure runs on Linux. I mean, think about that. It's the bedrock of the modern internet, which, as you can probably guess, makes it a massive, massive target.
And that is exactly why mastering Linux is so critical for something called ethical hacking. Now, this is not what you see in the movies with some shadowy figure in a hoodie. Nope, this is the legitimate practice of simulating cyber attacks to find those weak spots and fix them before the real criminals get a chance to pounce.
So let's get into it. What makes this open-source operating system the undisputed champ for cybersecurity? I mean, what's its secret sauce?
Well, it really boils down to this powerful combo. First, it's just famously robust. It's tough. Second, you get this incredible granular control. You can tweak every little thing. And third, there's just this huge ecosystem of amazing security tools, like Nmap and Metasploit, that were literally built for Linux from the ground up.
Okay, but you can't just jump in and start using all the fancy toys. To really wield this kind of power, professionals have to master the fundamentals first. And that journey, it always starts at the command line.
At the very heart of Linux security is this simple but honestly profound idea, the principle of least privilege. All it means is that you only give a user the absolute bare minimum permissions they need to do their job, and nothing more. Just that one idea alone dramatically cuts down the potential damage if an account ever gets compromised.
And this isn't just some abstract theory. It's enforced using pretty basic commands. For example, a simple ls-la command can help you spot malware that's trying to hide in plain sight, while sudo apt update is your lifeline for patching the latest vulnerabilities. It's how you turn day-to-day administration into a really powerful defense.
All right, so once those basics are locked down, the pros start building out their ethical hacking labs, and they do it using specialized toolkits that run right on top of Linux. And when we talk about toolkits, there's one name that everybody knows, Kali Linux. Seriously, the best way to think of it is as a hacker's Swiss Army knife. It's a version of Linux that comes preloaded with over 600 tools for penetration testing. It's all just ready to go, right out of the box.
But, and this is super important, the very first thing a professional does is secure Kali itself. It's a process called hardening. They change default passwords, shut down services they don't need, basically making sure their own powerful toolkit can't be turned around and used against them.
So you have all these powerful tools. How do you run them safely without messing up your main computer? Well, often the answer is a technology called containerization, and the most popular one out there is Docker. It basically packages up an application into its own little isolated, lightweight bubble.
The real magic here is isolation and speed. A pro can instantly spin up a tool like Nmap to scan a network, or Metasploit to test an exploit, and know that it's completely separate from their host system. It's just a clean, efficient, and really secure way to do your work.
Okay, so the lab is set up, the tools are ready. Now the real fun begins. This is where you have to learn to think like an adversary so you can get ahead of their moves.
And that brings us to a really crucial question. Imagine you're looking at a list with thousands of potential security flaws. How on earth do you know which one to fix first? How do you measure that risk?
Thankfully, you don't have to guess. The industry has a couple of standard systems for this. First, there's CVE, which is like a public dictionary of every known vulnerability. And then there's CVSS, which gives each of those vulnerabilities a score from 0 to 10, telling you just how bad it is.
And that score isn't just pulled out of thin air. It's calculated by looking at things like the attack vector, how it's exploited, and its potential impact. This is how teams prioritize what to patch right now, like with the infamous Log4Shell vulnerability, which, that scored a perfect 10.
But knowing about a single vulnerability is just one piece of the puzzle. To understand the bigger picture of how an entire attack unfolds, defenders use this strategic model that was actually developed by Lockheed Martin. It's called the cyber kill chain.
This framework is so cool. It breaks down a complex attack into 7 distinct, predictable stages. It starts with reconnaissance, the bad guy scoping things out, and goes all the way through to their final goal, like stealing your data.
So by understanding this exact sequence, defenders can actually map their own defenses to every single stage.
It turns into this strategic game where the goal is to break the chain at the earliest point possible, stopping the attack long before it ever succeeds.
But even with the absolute best systems and the most brilliant strategies, all the research points to one persistent weakness, and that's just simple human error.
Which kind of leaves us with this final thought to chew on. If defenders have the tools, they have the secure operating systems, they have the strategic blueprints to stop attacks, why does the human element, from just one weak password to a single click on a phishing email, remain the most persistent vulnerability of all?